You're free to go.
Great. Hi, I'm Ben Lewis. Thanks for coming to this seminar. I manage the WorldMap project here at Harvard. I work for the Center for Geographic Analysis. It's a technology platform. It was set up about 6-7 years ago to be a discipline agnostic center that would support all schools, all departments, all disciplines across the university, law school, business school, school of public health, humanists, historians, sociologists, economists, with anything geospatial. And we do all kinds of things from tiny little geocoding jobs up to building whole systems. And the WorldMap system actually grew out of a project, and we continued it because it filled one of the core parts of our mission, which is to build technology platforms so that we can leverage ourselves and get more done with fewer people. So with that, I want to ask you guys all a question. And if there we go. How many of you use open source software regularly? Now, some of you may say, I use it a lot. Some might say, well, I rarely touch it. But I would submit that you all use it all the time. And I would say that because the web, and I'm assuming that you all use the web, pretty much runs on open source software between Apache and Nginx for web servers and Linux for operating systems. It's everywhere. Many core platforms are open source now, as perhaps some or all of you know. Even Apple's operating system is open source. It's a version of Berkeley, Unix, Windows. ArcGIS uses Google, which is an open source translation engine. So in other words, ArcGIS uses an open source component for core technology. Google Earth also uses Google. Google, Facebook, Twitter, they all are built on open source software, much of it Python or Hadoop and many other things. U.S. military, massive user of open source GIS. These are the reasons. I thought they were quite interesting and very well put, right? Redeployability, vendor neutral, cost effective, highly adaptable. A couple links here in case they're of use. These slides will all be available to anyone who wants them. Just saw this White House directive. This is just out a couple weeks ago, saying basically, you know, there is going to be a policy that requires open source software be sort of the default. I mean, you're going to have to make an argument if you're not going to use open source software. Okay. So why do people give away valuable code? And I just want to touch on this for a moment because I think it's really important for understanding the importance of open source software. So in a very core scenario, the boss of the company, it's a software company, it's a health company, it's a whatever company. They have IT needs and they need to get a job done quickly and it needs to be robust. The developer and the boss doesn't care how it's done. The developer wants to do well and get a raise. So the coder, the developer, goes out, finds the closest thing he can find in the open source world, customizes it or uses it as is or builds a wrapper around it, and bingo, in a very short time, the coder has delivered a solution, just one guy. It's robust, And the coder has built his own network in the course of doing that. He's added some bit of improvement to the existing open source, and in the process of doing that, he has built his street cred with the within a global network of top computer people. Okay, so that improves his own personal worth. At the same time, he improves his company's bottom line. And he's paid to do it. So the company is paying him to write open source code. Okay, just a key idea there. Okay, so WorldMap. WorldMap developed out of an Africa map, a project called Africa Map, started in 2008. Professor came to us and said, I've got a gazillion data sets and photos and images and historic maps, and I'd like them all made accessible on the web in a mapping environment. And so we jumped into that. That kind of fit in very much with what I was wanting to do, and we built something quickly, and people loved it. And they would look at Africa Map and they would say, wow, can you do that for Baltimore? Can you do that for geology in Vermont? You know, can you do that for World's Fair maps in Paris? To which we would say, sure. And we would then clone the system and build Paris map and Boston map and China map and so on. And soon we realized that we needed to re-architect the whole thing and make it so that people could build their own mapping systems without needing our help or much of it. Original objectives needed to be high performance. It had to be fast. If it wasn't going to be fast, we weren't going to do it. If it's not fast on the web, it doesn't exist. It might as well not be there because people are spoiled. Google has spoiled us and many other companies which understand the value of people's time and people's quickly shortening attention spans know that performance is key. It needed to be scalable because we wanted to make it allow anybody to create their own maps and map collections and add data. We clearly wanted to support online collaboration. It needed to be highly interoperable because we knew it needed to connect with other systems. It needed to be extendable because we knew whatever we built, people would want more. And it needed to have a low cost of ownership. We couldn't be locked into some agreement with a private company that could, change its terms and, might go out of business, and then we'd have to figure out how to rebuild the whole thing. We needed to be independent, and it needed to run on commodity hardware. And we needed to get a beta version done in under 6 months, and we had one developer. Okay, that's what we needed to do. Now I'm going to give you a little bit about WorldMap, and in the process try to explain how we met those requirements. So the core idea of WorldMap is to lower barriers for people, anybody, researchers, but really anybody in the world, because it's a public-facing application, lower barriers for anyone who wants to use geospatial technology. It's cloud-hosted. We host on Amazon. It's available to the world to use. That is, this instance of WorldMap is available freely to anyone to use. But the underlying software is also open and available for anyone to download and set up on their own server, whether it's an Amazon server or really on any kind of, it's oriented towards Linux, but it could actually run on Windows if somebody wanted to do a little adapting. Service-oriented architecture is key. And what that really means is everything in WorldMap has an API on it. Everything in WorldMap can show up in another person's system, in another organization's system. And anything in those external systems which make use of open protocols can show up in our system. So service-oriented architecture, basically we speak we both read and write services using open protocols. This allows people to organize their data, visualize them, publish them, control access to their data. Key thing, you can keep your data private, or you can publish it to just a few people as you're collaborating, or you can open it up to the world. And that supports the research lifecycle within the academic space, but a lot of people use WorldMap who are outside of the academic space, whether they're in nonprofit, government, or private companies. Mash up and combine one's own data with the data provided by others. So while people can control permission access on their data, most, I would say 99% of people of the data sets in WorldMap, and there are now about some 15,000 data sets that people have contributed, 99% of them are available for others to use and view. And so there's a lot of mashing up that goes on within the system. And collaborating, of course. Multiple people can edit the same document. A quick graphic to sort of try to position where we see WorldMap's niche. It's between powerful analytics supporting desktop applications like ArcGIS, which have a fairly steep learning curve on the one hand, and can handle large amounts of data, and on the other hand, lightweight web apps like Google Maps, Google Earth, which are very powerful, very, very low learning curve, easy learning curve, but are very limited in the way that you can add your own data or collaborate around data in ways that you can, that are persistent, that you can go back to, that you can blog about, that you can represent as services. So here's an idea of kind of an openness stack, right? Openness has a lot of meanings. Open source code is just one piece. But as it happens, open source code is the best way to make all the other things happen. And I say that that's a fairly controversial statement in the GIS world. But I would totally stand by it. All my experience indicates that there is no better software for supporting open services and protocols and data formats than open source software, because if you think about it, if you're writing open source software and you don't support open protocols, nobody is going to use your software. It's just a no-brainer. Whereas with private companies, there's always a business calculation that has to be made with regard to supporting an open protocol versus supporting an internal protocol. And that's just the way it is. And that's all well and good. You just want to use the best tool for the job. Sometimes it's open source, and sometimes it's proprietary. So WorldMap connects to a lot of things outside of WorldMap. In addition to WebMap services, we connect out to Google Street View, Flickr, GRSS, and we're constantly building connectors as people come to us and say they want them. And by the way, usually when somebody comes to us and says they want something, and it's more than just a trivial, hour or two kind of a thing, it's a day or two of work or maybe a week or two, they come to us with funding, and that's how WorldMap gets built. And it's not grant funded, it's funded by users who want WorldMap to do things that it doesn't currently do or wants to improve it in this way or that way. And they've got $1,000 here, $5,000 there, an occasional $10,000 or $20,000, and that has not only allowed us to build the system, but it has also allowed us to expand it. Here's a graphic talking about how various users in various organizations can share resources by uploading, downloading, and also by using service protocols such that a map in WorldMap can show up in somebody else's application, and a map in somebody else's application can show up in WorldMap. Currently, we have about 12,000 users who are registered, many more who just use the system without being registered, and you can actually do a lot with WorldMap even without being registered. You just can't upload your own data, really. That's the main thing you can't do. About 15,000 data layers currently in there, at about 1.5 terabytes of data. 4,000 map collections. So 4,000, you could almost call them mapping applications, and I'll give you some quick examples of them in a minute. But things like, well, Africa Map, the original impetus for WorldMap, was a map collection, and now there are 4,000 of them. And if we had to build all 4,000 of them, we would have needed a team of 50 people working day and night over the last couple of years. And we've got about 750,000 visits in the last couple of years. So, and we don't advertise WorldMap. I mean, unless we consider this kind of a talk advertising, we're not pushing it. We talk about it within Harvard, but honestly, if it was announced, it's a delicate balancing act, keeping this much data and as many as 1,000 to 2,000 users a day using the system, keeping it performant, that I would much rather grow gradually than quickly. Graphic of traffic. So about 1/4 of the traffic is from Cambridge. Luckily, that's good. Occasionally I have to, I'm asked, by people higher up, deans, provosts, and folks like that, remind me why Harvard is making this platform available to the entire planet. Aren't we just supposed to be supporting Harvard researchers? To which I usually reply something like, well, believe it or not, the best geospatial data in the world does not reside inside Harvard. And if we want to have access to it, this is a way to get our researchers better access to more data and more collaborative relationships too. So WorldMap architecture. When we decided to make this kind of a content management driven platform, we chose to build on something called Geonode, which already handled security and pretty advanced styling quite well, and we didn't want to reinvent that wheel. It also brought together a bunch of best-of-breed components, PostGIS as the spatial, relational spatial database. You use OpenLayers as a map client. You use GeoServer as a map renderer, and these were all well-proven, well-supported components that Geonode basically wraps together in a Python framework called Django. And so we decided to build on Geonode, and that is really one of the most important reasons why we were able to build such a large system so quickly and have it be robust. I think right there is a great example of why open source is useful. Strengths. It let us build a big system, and so far it's scaled. Weaknesses, there are many moving parts, but with a collaborative mapping platform that's general purpose, there are going to be moving parts. I would say one of the, if I'm to be specific about weaknesses in this platform, it's probably GeoServer's ability to scale. And this is long-term something that we're going to have to deal with. So here is the sort of genealogy of WorldMap. It's built on Geonode, which is built on Django, GeoNetwork, GeoServer, and GeoEXT. And each of those pieces build on some very powerful libraries that are widely used in the IT world. Things like Lucene, Django, Goodle, Geos, Proj4, PostGIS, and so on. So we have one developer working for us, but in a sense we have thousands because we have thousands of people contributing improvements to these underlying pieces. Hosting costs are about $1,000 a month for WorldMap at the moment. It increases gradually. We're lucky in that Amazon has generously agreed to fund WorldMap and has funded it for the last 2 years. That is, they give us credits, and we can use those credits. We actually haven't had to pay our own hosting yet on this system. We're prepared to. We realize that we need to if and when this funding runs out, and it looks like, it will run out soon. We're going to apply for another grant, but we know that we can't be dependent on it. And really the cost of a full-time developer to maintain and extend it. And it really is more than a full-time developer position. It's more like a person and a half or maybe 2 people. And so we are, as WorldMap grows, and I'll explain some ways that it's growing in a minute, we're probably going to need to grow our team a bit. So just a picture of some of the organizations that have contributed to WorldMap and have contributed to Geonode. So these folks on the bottom, World Bank, State Department, NOAA, actually I left out United States military, DOD, or maybe I put that under the State Department. Okay. NOAA, Food Program, these fairly large organizations are all using Geonode. And so they're all contributing developer hours and resources to extending and improving Geonode. These groups here at the top have all are a sample of some of the funders of WorldMap. And WorldMap improvements feed into Geonode, and Geonode improvements feed into WorldMap. This is a diagram that explains schematically how we build functionality where we add major new capability areas without necessarily building it into WorldMap or into Geonode. So, for example, we have a project at Harvard called Dataverse, which is an open archiving system for social science data. It has no mapping capability, so we are now integrating with Dataverse to provide it with a mapping capability. Neatline is a storytelling platform, a very powerful kind of humanities-oriented map-based storytelling platform. Neatline does not contain a powerful way to host map layers. So, of course, WorldMap does do that. So we're working on integrating WorldMap with Neatline we don't want to build into WorldMap all of the fine-grained storytelling capabilities that Neatline does so well. We don't need to reinvent that wheel. Over on the left, edX is part of Harvard's HarvardX massive online education initiative, throwing a lot of resources into this whole new kind of experimental world of online education. WorldMap is being integrated with edX now to provide maps, to provide a mapping platform to support course developers, people who are building courses on the edX platform that require maps or geographic understanding or geographic questioning or the teaching of geographic concepts. MapWarper is an online map georeferencing platform. So if you have a scan, if you scan a map from the library, a paper map, you can upload it to WorldMap, georeference it online, and then bring it into WorldMap directly or as a map service. So all of these things are things that we don't want to go and build into WorldMap. They extend the power of WorldMap, but probably more importantly, WorldMap is able to help and extend the capabilities of these other open source platforms. I won't dwell on this, but just thought I would throw you an architecture diagram. I'll just leave this in here for the record. We can come back to it if you want to get into the details. But basically, you see there in the middle, there is an Amazon app server which is running Apache, Django, Geonode is running on that server, connecting to GeoNetwork, GeoServer, and a very, very important piece here that I have not touched on much is caching. So the only way that we are able to serve as many maps as we do to as many users as we do is by virtue of something called GeoWebCache, and there are other packages for doing this. This one works with GeoServer, and what we do is nobody, the system never renders the same map twice. So any map view that is requested is cached, and so it's caching on the fly. And probably 95% of views, and maybe even higher than that, it may be 99% of views, are views of maps that have already been cached. And so there's almost no CPU power required to serve that request. So caching is extremely important for web-based mapping applications that scale in order to support scaling. Of course, one gets into all kinds of issues if the data is dynamic that you're serving up, but we've been working on some solutions for that as well. Some quick examples just to give you a flavor of some of the maps that people have built and the kinds of things that you can do in WorldMap. This is a list of some classes that are using it. So let's see, this map put together by the Reischauer Institute, done after the Japan earthquake and tsunami and nuclear meltdown, and it brings together hundreds and hundreds of data sets on Japan. Many of these data sets were made available by the Japanese government and are only available here in WorldMap. They aren't online anywhere else, and that happens actually a fair amount of the time. An organization has some data, they want to get it out there, they don't have a platform to put it on, and so they'll load it up to WorldMap. This is a map that I just ran across the other day. I thought it was interesting. Somebody created this hazard viewer, and that's just an example of how people are just using the system to solve their own problems. It also points out the fact that this is not a library. WorldMap is not a library. We are not gatekeepers, and we don't attempt to be gatekeepers, nor do we pretend to be gatekeepers, determining which data is good and which data is bad. If we do hear that some data shouldn't be up there, that's copywritten or that's licensed, we will take it down. That has never happened. If somebody is writing obscenities somewhere, we would remove them, but that has never happened. So it's very much you could also think of it as a sandbox. People will say, well, how do I know which ethnographic map of Africa is right? Well, because there are 6 of them, right? All very detailed. To which we'd say, well, you're the researcher. You're to figure out which ones make sense, which combinations of them make sense. That's research. We're here to provide a platform to support your research to get you access to those 6 separate ethnographic maps of Africa. This is by the Boston Area Research Initiative, set up to encourage data sharing and enable data sharing between the City of Boston and academic researchers in the Boston area. Professor at University of Barcelona, bringing together planning data, historic planning data for Barcelona. Professor out at University of Iowa, who's working on mapping the decline of St. Louis. This is some work done on parcel mapping in Philadelphia. This is a women-run NGOs around the world, a map built by a foundation called the Virtue Foundation. A community wellness map created by an organization in Cambridge. Is done by the University of Mecca in Saudi Arabia. This is changing morphology of the city of Mecca, overlaying historic maps, and bringing together a whole lot of data sets on Mecca. Another map that I just ran across, I don't know the authors of this, some air pollution, air quality data, an example of overlaying a historic map on some of the base maps that are available. And while we support Google's base maps, we're not tied to them. We can bring in any base maps and make any of them available. Another map by the Virtue Foundation. We also have a large China project called China Map. Brings together a lot of contemporary data on China. What's coming? So HarvardX integration, which I mentioned, Dataverse integration, Neatline. We're building a big geospatial data, a big geodata archive, which we're actually just sort of building by our bootstraps. But the basic idea is, lowering the barrier for. Let me just whip to that. So there's HarvardX, Dataverse, Neatline. The Big Geodata Archive is about lowering the barrier to researchers and others to access of big geospatial data, which is right now pretty hard to get, obtain, let alone slice or dice or visualize. And so we're starting out with tweets, which we've been harvesting now. We've been harvesting geo-referenced tweets, that is those which come in off of mobile devices with GPS coordinates, which is about 2% or about 7 million a day. We've been harvesting those for the last 2.5 years, and now have about 5 billion tweets, which are really records of who is saying what, where, and when, which is a pretty interesting geospatial resource, spatiotemporal resource. And we are working on platforms to make that stuff easy to slice and dice and analyze. And that's sort of just the poster child, I think, for big geospatial data in general. And there are a lot of those data sets becoming available now. And so we're going to try to make those easier for people to get their hands on. And this project is something that a grant we landed last year, funded by National Endowment for the Humanities, to build a global registry of map services. It's going to be a public registry. It's going to have an open API on it. Our estimates, we estimate that there are millions of WMS and Esri REST image services out there, which are now, there's no easy way to discover them or find them, let alone bring them into your own application. And so we're going to build that registry. It will include everything in WorldMap. We'll use that. Our search within WorldMap will make use of this registry, but the registry will also be available to anybody to use from their own mapping applications. They don't need to be in WorldMap to use it. And that's about it for my talk, and I'd like to open it to questions.
Thanks, Ben. So all attendees, as I mentioned in the beginning, there's a little panel, or I should say in your GoToMeeting panel, there's a place for questions. And if you type them in, we can kind of have Ben walk through them now. So Ben, what I'm going to do is just read them off to you.
Okay.
And the first one we have is from Simon Lewis. It says, okay, how much of WorldMap is a map management and display tool versus a tool that can generate, store, manage, and use topology for spatial analysis?
That's a great question. So we have been occupying ourselves with the display and sort of very sort of simple level collaboration. But the underlying platform is very powerful and can support all kinds of spatial analytics, including topological analysis of various kinds. So to sort of find out what the full feature set there is, take a look at PostGIS and look at the spatial operators in PostGIS. In addition, GeoServer provides a very rich set of operators, an API in a sense for spatial operations. We are just now at the point where people are coming forward with funding and saying we want to build this spatial analytics piece into WorldMap. So it's always been there. I've always sort of said that it would be easy to expose, but we're still kind of, at least here, in the phase of people just really excited that they can map stuff. Here at Harvard we have a lot of people who are experts in their field, but they don't know anything about mapping, and they may not know much about technology, and so an economist or sociologist is just very happy to, create a choropleth. And but that is all very doable, and the underlying platform supports it well. Another platform that I should put a shout out to, which is really good in this regard and exposes PostGIS's capabilities very, very nicely, is called CartoDB.
Okay.
Yep.
Okay, right now it looks like you answered, with the response, you answered the other question that we had here, Ben. So we'll give everyone a minute to submit any other questions, but just since we had some echoing issues at the beginning, I'm just going to repeat some of the highlights or the housekeeping notes so everyone can get a chance to hear them. What I was mentioning in the introduction is we have our next webinar on Tuesday, December 9th, and it's entitled Pushing Backroom Data into a Public-Facing Google-Powered Travel Information Site, Drive, Texas, a case study by Rich Grady and Michael Turner from AppGeo. We also want to mention that we are going to be at the GIS-T event on November 13th at Burlington County College in Mount Laurel, New Jersey. Agenda will be on the MAGTUG site soon. And finally, if what Ben's talked about, and we have a question that an additional question, that case came in here, but before we go to that, if what Ben's talked about or just open source in general is of interest to your organization, we're holding a symposium on March 5th, actually, of 2015 at Villanova. So if you have implemented open source or have data applications related to open source, we're certainly interested in hearing from you and how you might want to participate in that symposium. Simon Lewis, who is on the MAGTUG steering committee, is running that, so you can certainly reach out to him via the magtug.org site. So, okay, so Ben, we have a couple more that came in. What is the WorldMap policy about who can register as a user?
Anyone can register.
Okay. And then can roles and permissions be applied to maps?
Yes. So maps and layers both have a permission regime. They can either be public. A data layer can be public and displayed and downloadable, or just publicly displayed and not downloadable. And then one can control who, if it's not public, who has access to it, and whether those people have the ability to manage and edit, or only edit. And the difference there is that managers can add and remove users.
Right, okay. Okay, we have another question that came in. Can we download the data into an ArcGIS format?
Yes, so most data sets in WorldMap are available for download as shape files. Here, I could even, would it be useful to show you anything? I don't know. I'm on the China map site here. I don't know if you want to show the page. Any layer in the system, you can right-click on it and go to the layer page. Every layer in the system has a control panel for it, and at the upper right of the control panel are all the ways the data can be downloaded. So shapefile, GML, Excel spreadsheet, CSV, GeoJSON, GeoTIFF, JPEG, PDF, PNG, and KML. Just about everything in WorldMap can be viewed, can be pumped straight into Google Earth with the symbology that's been defined in WorldMap.
Good. I think, yeah, that was good to show that. I think that was a good way to explain and talk through that question. So a couple more. How is metadata handled?
Right, so
go ahead.
When a user adds a data set, uploads a data set, or creates a data set in WorldMap, the user is provided with a form to use to fill in metadata about the layer. We don't do very much enforcing of metadata because this is, after all, this is not a library. This is about people solving their own problems, and so people can sort of put as much metadata as they want in for their layers. What we do require is that there be a title, an abstract, at least some kind of tag, and a ISO category provided. But those are the only things that we enforce.
And then, what would be necessary to set up our own instance of WorldMap? I guess how would that happen if someone wanted to do that themselves?
Right. So the easiest way would be to take our Amazon machine image, it's called an AMI, and simply put it on, fire up an Amazon server, which is very easy to do. You can create an account on Amazon and pick the size of server you want to run. You probably want to pick a medium or so, which, would, you'd have to check on the prices, but we're talking, you could probably get going for $20 a month kind of a thing, and just take our Amazon machine image and install it, and we'd be happy to help you do that. So that's the easy way. The other way is to download the source code from GitHub and install it on your own box. You could go that route and install it on Amazon, or you could install it on a local, on your Linux server in your data center, or on your local desktop. Some people run it from their laptops.
Okay. And then kind of in a related sense, but another question came in, and how is WorldMap different compared to ArcGIS and ArcGIS.com? Besides putting aside costs, right? What are just the differences if you have to compare the two?
Okay. So of course the biggest difference, there are a couple big differences. One, of course, is the difference that you have access to the code, but that's obvious. The other difference is that you can upload very large data sets to WorldMap, and you're very limited in doing that on the free version of ArcGIS Online. If you want to, I don't know exactly how, what we do, we have a license to, we get credits for running ArcGIS Online, but I don't know offhand what is consumed when one uploads, a 100 meg shapefile, but I think it's a fair amount. If we're talking about sort of free, WorldMap, which is an online free application, compared to, say, ArcGIS Online, the free version, then there's just a large difference in what you can load to the system. The other, perhaps more important difference is that anything you load to WorldMap you can get out in any number of open formats, including shapefiles, which are compatible with a wide variety of platforms. Another major difference is being able to handle raster and upload of raster images. I don't think that ArcGIS Online supports, at least last I looked, you couldn't upload a GeoTIFF, for example. So those are a couple things. Interoperability. Oh, the other one is everything in WorldMap is a map service. So if you load your data to WorldMap and you want it to show up in, another application, it could be ArcGIS Desktop. It could be your own. Let's say you create your own web mapping application, right, for your site, and you want a map from WorldMap to show up in it, and so that therefore you wouldn't have to set up your own map server. You just set up a client, bring your layer in. You can do that. I don't think you can get map services out of ArcGIS Online, at least the free version. Maybe there's a paid version that you can use. But please correct me if I'm wrong. If anybody on the line is knowledgeable about this and can correct me, please do. I'm not trying to sell WorldMap at the expense of ArcGIS Online. I do know that a lot of people here at Harvard try ArcGIS Online because they've heard about it, and then they end up using WorldMap because they're able to get their data in and out of it.
Right. So one correction that did come across the line, Ben, is that with ArcGIS Online, there's no consumption of credits for uploading. It's really for the storage. Just a point of clarification that did come across as you were speaking.
Okay. But for the free version of ArcGIS Online, I think you can only upload 1,000 features, which is a very small file.
Yep.
Yeah.
Okay, so we have a couple more. Let's see, is there an API that a developer can program against, or would one have to program against the APIs of the individual components?
So there's every layer has an API available. It's WMS and WFS. So these are standard APIs for map layers. There are lots of other APIs. It sort of depends on what the user wants to do, but pretty much everything can be accessed via an API.
Okay. And then there's one final question here, Ben. Is Harvard's plans, or I should say another one just came in here, but we'll read through this one first. Is Harvard planning to keep WorldMap free for use with no limitations for data uploading?
As far as I know, yes. I haven't heard any indication otherwise.
Okay. And then a couple other just trickled in. iOS, Android support. Is there any for like data collection? You can, I guess in the context where there's the collector app for ArcGIS.
That's a fantastic question. So we started a very preliminary mobile client for WorldMap a year or so ago, but I would say it's probably pre-alpha, but it does support very basic use in the field, including editing of features in the field and the creation of features in the field. It needs work. I think it's it's something I would very, very much love to either build or help someone build, or have somebody want to do. I think it would be very, very powerful.
Good. Okay, I think that wraps it up. The other question I had were related to the PowerPoint being available. We will post this on the MAGTUG website for everyone to access. Thank you, Ben Lewis, again for taking the time to kind of educate us on WorldMap and what Harvard's been doing. And thanks everyone for hanging around. I know we had some technical difficulties in the beginning, but hopefully this was beneficial, and we look forward to everyone joining us next time. Have a great day, everybody.
Thank you.